Okay, hello friends. Um, I have been talking to some of my uh, uh, colleagues and friends about this whole topic regarding artificial intelligence, right? And when I've been speaking, what one thing which I've realized is that everybody is aware of it. Everybody is quite fascinated by the topic of artificial intelligence, but somewhere, there is a confusion, there is an anxiety as to what does it mean for me, right? Some of the folks I worked is, somebody who works as a, early career professional in a services company, working in a, business operations function, or a late career, person who's working in the, IT services function, and so on and so forth. And then, different people are doing different things, right? Some people are have signed up with some courses for artificial intelligence, and some people are trying to get into projects related to artificial intelligence in their company, and so on and so forth, right? But nobody seems to have that clear picture of what needs to be done, how do they need to go about it. So I thought making a small video will be helpful. So what I've done is that worked on creating a structure, and this is based on two things, right? One is that artificial intelligence, I think, is not new to anybody, right? So nobody can say that they don't know anything about artificial intelligence. But I think the point is that can artificial intelligence become a career platform for me? Can artificial intelligence be a part of my career somewhere? And we hear this thing often these days that artificial intelligence robots are not going to replace you, but we are going to be replaced by people who know how to use artificial intelligence in their work, in their daily lives, right? So therefore it's important to have the knowledge. Therefore it's important to be on a journey. And I think each any organization that we work for will probably put in certain amount of effort to help us on that journey, but then we also need to make that effort ourselves, right? So that's the context, to help you all understand a little bit more about what AI is and put you on the journey for AI. And of course, it's up to you which direction you want to take. You want to become like an artificial intelligence solution architect and you want to go that way, or you want to become a programmer and learn more about the programming technologies, or you want to become more of a operational excellence or a business analyst which is looking at different business scenarios and how to implement that. But for all of them, you need to understand some basic concepts like what is artificial intelligence, right? You need to understand a little bit about the history of artificial intelligence. There are three broad periods. One is, of course, before 1800s, what happened, and then from 1800s, or rather, I can say before 1900s, what happened. Then from 1900s till the AI winter, so to speak, which happened. There was a lot of work which happened in the 1900s up till about the time when the Dartmouth workshop had happened. But then after that, things went into an AI winter. But then it has really, come back into the scheme of things once the whole thing about the deep learning, the neural networks, and the convolutional neural networks and the foundational models, got invented. Right. Since then, it's been on a huge upswing. Right. So we need under a little bit. We need to understand a little bit about history, and also I can explain one thing is that AI is not completely new to all of us. We've all seen the journey, right? Those of us who have worked with small macros in Excel, what is that? At the end of the day, that's also converting a certain intelligence to work, right? So just keep that in mind. There have been different stages of automation and artificial intelligence. So scripting, and then we went on to robotic process automation, then we went into analytics, and now how do we take that analytics and help it to work in the artificial intelligence domain. So what is this artificial intelligence? We need to understand that in the history. And then there are so many different ways to categorize artificial intelligence. Okay. You will hear a lot of terms these days. You hear a term called for example, narrow AI, general AI, super intelligent AI, and so on and so forth, right? So what does all this mean? There's another way of looking at AI is, that AI is natural language processing, AI is computer vision. What is that? Speech to text and text to speech, and where do they apply, and the autonomous vehicles, all of that stuff, right? Once we understand this at an overview level, we need to then get into the next level of things, saying that, okay, how does it actually work, right? So, we say that AI is about helping humans to think, or mimicking the process of humans thinking. So how does that work? So that's where machine learning, deep learning, classification, clustering, neural networks, convolutional neural networks, of course I'm throwing a lot of jargons at you, but just to get you interested, right? And so the remaining part of this video will also talk about some of those things. So large language models, foundational models, and how do all of these things link with each other, right? Where does the story come together? Then, of course, very important is the tools. What are some of the tools, underlying technologies which are being used? I think all of you must have heard about Python. That's an amazing programming language. It has got many, benefits. It's very user-friendly, easy to use, and faster than other languages like C++ and so on. And it's got so many modules and libraries associated with it. Then we also need to then move on to understand what is regression, what is random forest, what is k-means processing, and so on and so forth. And then last but not least, if each one of us has to build an AI model in our own lives, how do we actually go about it? And how to actually start learning about AI, right? There's so many resources these days. There's Kaggle, there is GitHub. There's just an amazing amount of stuff. You won't believe, for generative AI alone, there is a 30-hour video in YouTube, right? I'm sure if you're able to dedicate the time, ready to, sacrifice your weekends, those who are working professionals can definitely be on this journey. So with that small introduction, I will pause now, and I will, connect it to the remaining part of the video. So enjoy yourself, have fun. And of course, if you want to discuss more about it, if you feel that you want somebody like me to, be a part of your journey, to have a discussion, please feel free to reach out. Thank you.
With that context shared by Sundar, I am your host today, and let's dive into our agenda for today. Artificial intelligence is a term that sparks both wonder and apprehension. Like gazing into a distant galaxy, we are drawn to its enigmatic allure. We stand on the cusp of a new era, one where machines are evolving from simple tools to intelligent collaborators. But what exactly is artificial intelligence? Where did this idea originate? And what does the future hold as AI becomes increasingly intertwined with our lives? This is the story of AI, its past, its present, and its awe-inspiring potential. Artificial intelligence, or AI for short, is a branch of computer science. It focuses on creating machines that can perform tasks that typically require human intelligence. Think of tasks like problem-solving, learning, decision-making, and understanding human language. Imagine a computer that can analyze vast amounts of data. Then it can identify patterns and make predictions. That's AI at work. Examples of AI are all around us. Voice assistants like Siri and Alexa use natural language processing to answer your questions. Self-driving cars rely on computer vision and machine learning to navigate roads. And recommendation algorithms on platforms like Netflix and Spotify use AI to personalize your entertainment experience. These are just a few glimpses into the growing presence of AI in our daily lives. The quest to create artificial intelligence is not new. It's a story that stretches back centuries. The ancient Greeks told myths of Hephaestus, the god of fire, who created mechanical servants. These stories reflect an early yearning to imbue inanimate objects with intelligence. In the 17th century, philosophers like Leibniz and Descartes explored human reasoning as logical calculations. Their work laid the groundwork for logic and computation. In the 19th century, Charles Babbage's analytical engine and Ada Lovelace's programming vision further fueled the dream of intelligent machines. The 20th century marked a turning point in the history of AI. Alan Turing's work on computation and the Turing test in the 1950s provided a framework for machine intelligence. The Dartmouth Conference in 1956 formally established AI as a field of study. The following decades saw both excitement and setbacks. Early AI systems showed promise in game playing and theorem proving. But limitations in computing power were challenges. Despite hurdles, AI research advanced. Neural networks opened new avenues for machines to learn from data. Deep learning in the 21st century led to breakthroughs in image recognition, natural language processing, and robotics. Part 5. Envisioning the next 50 years, AI's potential. Gazing into the future of AI is like peering through a telescope at a distant galaxy. We can discern its general shape and the brilliance of its core, but the intricate details remain tantalizingly out of reach. The next 50 years will witness an unprecedented acceleration of AI capabilities. AI will transform industries, augment human potential, and pose ethical questions. In healthcare, AI will personalize treatments and extend lifespans. Imagine AI assisting doctors in making faster diagnoses. Smart prosthetics will restore mobility to those with disabilities. And AI-driven drug discovery will develop life-saving medications. Beyond healthcare, AI will reshape our cities and transportation. AI-powered tools will automate tasks, freeing humans for creative endeavors. Part 6. Classifying the categories of intelligence. As per current understanding, AI is of 3 types: narrow or weak AI, general or strong AI, and superintelligent AI. Narrow AI represents the most common type of AI we encounter today. These AI systems are designed to perform specific tasks, such as playing chess, recognizing faces, or translating languages. They excel in their designated domains, but lack the general intelligence and adaptability of humans. General AI is a hypothetical type of AI that possesses human-level intelligence and cognitive abilities. A general AI system would have the capacity to understand, learn, and apply knowledge across a wide range of tasks, much like a human being. While general AI remains a topic of ongoing research and speculation, its development would mark a significant milestone in the evolution of artificial intelligence. Part 7. Unlocking AI's power machine. Learning and deep learning. At the heart of many AI breakthroughs lies a powerful set of techniques known as machine learning. Unlike traditional programming, where computers are explicitly told what to do, machine learning allows systems to learn from data, identify patterns, and make predictions without being explicitly programmed for every scenario. Deep learning, a subset of machine learning, takes inspiration from the structure and function of the human brain. It leverages artificial neural networks, which are composed of interconnected nodes organized in layers. These networks can process vast amounts of data, learn complex patterns, and make highly accurate predictions. Machine learning and deep learning are powering a wide range of AI applications, from image recognition and natural language processing to fraud detection and medical diagnosis. These techniques are enabling machines to perform tasks that were once thought to be the exclusive domain of human intelligence. Part 8. More about ML and DL. ML is a subset of AI. It includes various approaches like supervised learning, unsupervised learning, and reinforcement learning. Supervised learning involves training a model on labeled data, where the input-output pairs are known. Consider, for example, a model to predict the price of an apartment based upon its area and proximity to the city center. We can use linear regression model here, which is an example of supervised learning. Unsupervised learning, on the other hand, deals with unlabeled data, aiming to find hidden patterns or intrinsic structures. An example would be customer segmentation. It can group customers based on their common traits or purchasing behaviors, which can help businesses create better buyer personas. Reinforcement learning is about training models to make sequences of decisions by rewarding desired behaviors. It uses a trial and error process to teach an agent how to behave in a given environment. RL can be used to train cars to navigate complex environments like city traffic. Natural language processing, NLP, and computer vision are 2 significant fields within AI. Natural language processing, NLP, is a branch of artificial intelligence that enables computers to understand, interpret, and generate human language. In simpler terms, it allows machines to talk and listen to us in a way that feels natural. What happens in NLP? Understanding language. When you speak or type something, NLP systems first need to understand what you're saying. This involves breaking down your words into manageable pieces, tokenization, and identifying their meanings. Processing input. The system processes your input by analyzing the structure of your sentences, syntax, and the meanings of the words, semantics. It looks for context and intent behind your words. Generating responses. After understanding your request, the system formulates a response. This could involve generating text or converting it into speech. Practical example with Alexa or Siri. Let's say you ask Alexa, "What's the weather like today?" Voice recognition. First, Alexa uses speech recognition technology to convert your spoken words into text. This is the machine's way of hearing you. Understanding intent. Next, NLP algorithms analyze the text to determine that you are asking for weather information. It identifies keywords like weather and today. Fetching information. Alexa then accesses a weather database or API to retrieve the current weather data for your location. Generating response. Finally, Alexa constructs a natural-sounding response, such as, "Today it's sunny with a high of 75 degrees," and converts this text back into speech so you can hear it. Computer vision, CV, is a field of artificial intelligence that enables computers to interpret and understand visual information from the world, similar to how humans see and comprehend their surroundings. In simpler terms, it allows machines to see and make sense of images and videos. What happens in computer vision? Capturing images. Just like our eyes capture light to form images, computer vision systems use cameras or sensors to take pictures or videos of the environment. Processing visual data. After capturing the images, the system processes them. This involves breaking down the image into tiny pieces called pixels, which are the smallest units of an image. Each pixel has color values that help define what the image looks like. Understanding content. The system analyzes these pixels to identify patterns, shapes, and objects within the image. It uses algorithms, sets of rules, to recognize features such as edges and textures. Making decisions. Once the computer understands what it sees, it can make decisions or perform tasks based on that visual input. For example, it might identify an object, track movement, or classify images. Practical example with self-driving cars. Let's say you're in a self-driving car that needs to navigate through a busy street. Image. Capture. The car uses cameras to capture real-time video of its surroundings. Processing input. The computer vision system processes these images frame by frame, identifying various objects like pedestrians, other vehicles, traffic signs, and lane markings. Understanding context. The system analyzes the shapes and movements of these objects. For instance, it recognizes a stop sign and understands that it needs to stop. Decision-making. Based on this understanding, the car makes decisions such as slowing down, stopping at a red light, or changing lanes to avoid obstacles. Various algorithms play a pivotal role in these fields, including regression, logistic regression, random forest, KNN, and support vector machines. Regression analysis helps in predicting continuous outcomes, while logistic regression is used for binary classification problems. Random forest is an ensemble method that improves prediction accuracy, and KNN is a simple, instance-based learning algorithm. K-nearest neighbors, KNN, is a machine learning algorithm that classifies or predicts data points by comparing them to their nearest neighbors. It's a supervised learning algorithm that's used for classification and regression problems. Support vector machines are powerful for classification tasks, especially in high-dimensional spaces. They classify data by finding the best hyperplane to separate data points into classes. SVMs can also be used for regression and outlier detection. By understanding these subsets and algorithms, we can better appreciate the advancements and future potential of artificial intelligence. Let us now know more about DL. It is a subset of ML. It focuses on using neural networks with multiple layers to analyze vast amounts of data, enabling machines to perform complex tasks such as image and speech recognition, natural language processing, and autonomous driving. The term deep refers to the number of layers in the neural network, which can range from a few to hundreds or even thousands. How deep learning works. Deep learning models operate through a process that mimics human brain function. Here's a detailed breakdown. Neural networks. At the core of deep learning are neural networks, which consist of interconnected nodes or neurons organized into layers. Input layer. This layer receives the raw data, for example, images, text. Hidden layers. These layers perform computations and feature extraction. Each neuron in a layer is connected to all neurons in the previous layer, allowing for complex transformations and abstractions of the data. Output layer. This layer produces the final prediction or classification based on the processed information. Training process. Deep learning models learn by adjusting weights and biases associated with each connection between neurons. The training process involves forward propagation. Data is passed through the network from input to output, generating predictions. Loss. Calculation. The difference between the predicted output and the actual output, ground truth, is calculated using a loss function. Backpropagation. The model adjusts its weights based on the error calculated, allowing it to improve over time. Activation functions. These functions determine whether a neuron should be activated or not, introducing nonlinearity into the model. Common activation functions include ReLU, rectified linear unit, sigmoid, and softmax. Data requirements. Deep learning models typically require large datasets to train effectively, as they need to learn intricate patterns that simpler models may not capture. Examples of deep learning applications: computer vision. Convolutional neural networks, CNNs, are widely used for image classification tasks. For instance, they can identify objects in images or classify medical images for disease detection. Natural language processing, NLP. Recurrent neural networks, RNNs, and transformers are employed in applications like language translation and sentiment analysis. Models such as GPT-3 utilize deep learning for generating human-like text. Speech recognition. Deep learning algorithms can transcribe spoken language into text, powering virtual assistants like Siri and Alexa. Autonomous vehicles. Deep learning enables self-driving cars to interpret sensor data, recognize obstacles, and make real-time decisions. Part 9. Charting your course. Embracing the world of AI. The world of AI is vast and constantly evolving. But the journey of 1,000 miles begins with a single step. If you're intrigued by the potential of AI and eager to embark on your own exploration, here are a few steps to guide your path. 1. Embrace curiosity. Cultivate a thirst for knowledge and a willingness to explore new concepts. The field of AI is constantly advancing, so a curious mind is essential. 2. Start with the fundamentals. Build a strong foundation in mathematics, particularly linear algebra, calculus, and statistics. These subjects provide the language for understanding AI algorithms. 3. Learn a programming language. Python is an excellent choice for beginners and is widely used in AI development. Familiarize yourself with its syntax, data structures, and libraries. 4. Explore online resources. Take advantage of the abundance of online courses, tutorials, and communities dedicated to AI. Platforms like Coursera, edX, and Udacity offer high-quality courses from leading universities and institutions. 5. Get hands-on. The best way to learn AI is by doing. Start with small projects, experiment with different algorithms, and gradually work your way up to more challenging problems. 6. Join the community. Connect with other AI enthusiasts, attend meetups, and participate in online forums. Collaboration and knowledge sharing are essential for growth in this rapidly evolving field. 7. Stay informed. Keep abreast of the latest advancements, research breakthroughs, and ethical considerations in AI. Subscribe to industry publications, follow thought leaders on social media, and attend conferences to stay informed. The world of AI is brimming with opportunities for those with the curiosity, passion, and determination to explore its uncharted territories. The future of AI is not predetermined. It's a story that we are all writing together, one line of code, one breakthrough, one ethical consideration at a time. So, embrace the challenge, ignite your curiosity, and embark on your own extraordinary journey into the heart of artificial intelligence. Remember, the journey into AI is not just about the destination, but the experiences and knowledge gained along the way. Celebrate your milestones, no matter how small, and keep pushing forward. Plan your next steps, set new goals, and continue to explore the ever-expanding world of AI. The path may be challenging, but with perseverance and passion, the possibilities are endless. The future of AI is in your hands. Embrace it, shape it, and make your mark on this incredible journey.